Hey there, everyone. Welcome to your second week of hybrid learning. And our asynchronous lesson today is about heat transfer. So go ahead and open up your heat transfer notes. You'll be able to fill those out while watching this video. So the first thing we got to talk about when we talk about heat transfer in our atmosphere is where does all that heat come from? Spoiler alert, it's the sun. So the sun is the primary energy source for Earth. So I know that we just got out of our unit about the Earth's core, right? And the hottest place on the Earth is the center of the Earth, the inner core, due to all that heat and pressure. But a lot of that heat doesn't make its way all the way to the surface. In order to heat our atmosphere, and the majority of our energy that we see and experience comes from the sun. Earth's climates and weather patterns are a direct result of the uneven heating of Earth's surface. So that sun, we have to get a lot of credit, for sure. Now, when the sun emits energy, it emits energy in the electromagnetic spectrum. So it's a lot of syllables going on there, but electromagnetic spectrum is just the energy that's emitted from any star. And any star that emits energy from the electromagnetic spectrum will do so along all wavelengths. So what that means is that, yes, everything that we see is visible light. But notice, visible light is only one type of radiation emitted from the sun. The sun actually emits energy along all of these frequencies and wavelengths. It emits radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, gamma rays. All sorts of radiation comes from the sun. And our eyes have only adapted to see a very narrow portion of it. Out of all of the frequencies that are emitted from the sun, we can see just this tiny little sliver, just this tiny little amount. There's so much that we can't experience because we don't have the ability to perceive it. But that doesn't mean it's not there. For instance, long wave radiation is okay to be exposed to. That long wave radiation means that we have longer wavelengths. Look at that wavelength stretching out over here. Those have lower energy levels. So radio waves, microwaves, infrared, which is just heat, all of these have lower energy levels. So it's okay to be exposed to them. If you go stand next to a microwave and a radio, you're not going to get cancer. Nothing's going to happen to you because the wavelengths won't interfere with the cells in our body. The wavelengths are too long. However, the short wave radiation, be very careful because that can be very dangerous. The shorter these waves get, aka the higher the frequency, the more energy that those waves pack, and they actually have the ability to go through our cells and alter our DNA. So ultraviolet light, which is one step up energy-wise from visible light, that's why we wear sunscreen when we go outside. It blocks those UV rays from interfering with our cells. And the shorter that wavelength gets, the riskier it is for it interfering with our DNA. So X-rays is another one, gamma rays is another one. Now, that doesn't mean if you've gotten a lot of X-rays that you should panic. No, if you're getting thousands of X-rays a year, you should be careful. But most of us, we're functioning just okay. It's actually worth it to get an X-ray and see what's going on inside of our bodies rather than saying no because of the very minute risk of getting damage from that single X-ray. It's a lot of them that add up over time. So again, visible light is the only portion of the spectrum that we can see. However, there are animals that have adapted to see ultraviolet light. And there's animals that have adapted to see infrared light. So if you look in your notes, there's a couple links there for you. You don't have to read them, but you certainly can. Adaptation and evolution is just fascinating. So the sun emits energy, and that energy is the electromagnetic spectrum. It's light. It's all sorts of wavelengths that we can experience. Yeah. So in your notes, you have this wonderful picture. Just keep in mind, the longer the wavelength, the more stretched out the wave is, the lower the energy, and the lower the risk it is. This isn't going to cause us that many problems. But if we shorten up that wavelength, shorter wavelengths have high amounts of energy, and that's what can really impact our bodies. Now, visible light is just a very small portion. That's what we can see. Infrared, that's heat. And we're going to be focusing on infrared and visible light for this week. Yeah. So let's talk about atmospheric heating. And before we can do that, we need a quick reminder on the 3 ways that heat can be transferred. This is something that you covered in 6th grade and something we've talked about this year, but I don't think we've ever actually written it down. So conduction over here is the transfer of heat through contact. So that's if you actually touch something, you're like, ooh, that's hot. That's conduction. So any heat transfer through contact, boom, that's conduction. Radiation, which usually gets bad connotation, right? Radiation poisoning, but radiation in general in science is just the transfer of energy through space. So it's any time that heat is being transferred from one thing to another across open space. We happen to get all of our energy from the sun through radiation, and that's not a bad thing. We need that to happen. The final one, we've actually talked about quite a bit in our last unit, which is convection, the transfer of energy through fluids. And remember, fluids can be liquids or gases. It's anything that flows. And convection, really, that transfer of heat that we're talking about is we have a heat source, and it heats up particles in our fluid, and it causes them to become less dense, and they rise. Then the cooler things sink and take their place. And that's what convection is. We got hot things rising, we got cool things falling. It's a transfer of energy. And so these are the main three types of heating methods, but how does it pertain to our actual atmosphere? So in your notes, there's three pictures for you to double click on. The first one is radiation. So in your drawing, double click on it, you're going to type in this definition, which is solar radiation travels through space to warm the earth. So what you're going to notice is our atmosphere itself doesn't just boom, get warm from the sun. That's not actually how it works. In order for the atmosphere to get heated, the first step is the sun has to actually hit the surface of the ground to absorb the energy. Air is not super dense, and it doesn't have a really high capability of absorbing sunlight. It does absorb some, and some particles are better at absorbing than others. But most of air is empty space. So the best way for air to get heated is for the first step, the ground is going to get heated. Because the ground is darker in color, it's way more massive and has more volume, so it's going to be able to absorb that sunlight. So step one of atmospheric heating is solar radiation travels through space and warms the earth. After that, our air can get involved, and this is where we have our conduction. Air molecules, in order to heat up, actually contact the ground. Very few air molecules get warm directly from the sun. It takes this indirect contact in order for it to work. So the sun heats up the ground. The ground is now warm. You can see these red particles. These are actually representing air particles that are now warm because they've made contact with the ground. That's conduction, anytime we have that direct contact. So now we have our air molecules that are heating up down here by the ground. Our last step is convection. Because remember, what do hot things do? Yeah, just like in our last unit, hot things rise. And the same thing happens in our atmosphere. As these particles hit that hot ground, they start to rise because they become less dense. And that ends up heating the rest of the atmosphere. It brings the heat from the ground and it rises throughout the rest of the atmosphere, allowing for a more moderate temperature. So instead of just having really, really hot air at the bottom and really, really cold air at the top, it kind of circulates through. And that's really important for our survival and for our weather patterns. So if we take a look at our heat movement, this is like overall the atmosphere moderating its temperature. Heat will always move from areas of high heat energy to areas of low heat energy. That will always happen because it seeks balance. That's what the universe constantly tries to get to. So when molecules receive more energy, right? So the molecules, they hit the ground. The ground is really hot. As they heat up, taking up more space. Remember, those hot particles have more energy, so they're going to expand, allowing them to have a larger volume. And when that happens, they become less dense. And that is why hot air rises. So the warmer the air is, the faster it's going to rise. And the colder the air is, it's more dense, so it's going to sink. And that's what causes wind to happen in our atmosphere. Hot air rises, and that doesn't cause us to suffocate, right? We're not like missing air. Cold air rushes in to take its place. And that's why yesterday when we had that huge amount of wind that was blowing around, it was because we had big temperature differences. The bigger difference we have in temperature, the bigger difference we have in pressure. And that means we're getting wind. So that's how our atmosphere is heated, right? We got warm air rising, cool air sinking. It causes atmospheric heating and wind. Now, the greenhouse effect is indeed a factor, and that's something that we're probably going to keep an eye on throughout our entire lives. So greenhouse gases cause sunlight to reflect back towards the earth. So there's a couple videos for you to watch. Pick one of those videos to watch it all the way through, and take your own notes on this process. But the greenhouse effect, it has to do with the types of gases in our atmosphere, with the composition of gases in our atmosphere. And if we keep increasing our greenhouse gases, we're going to continue to see this heat reflected back towards the earth. So watch one of those videos, get a better idea of exactly how does this happen, and finish your notes on your own. Thank you very much for watching, everybody. I hope you have a wonderful week, and I look forward to seeing you in class.